The sun, which is really far away, emits a lot of energy, right? It emits a lot of energy, and that energy reaches the Earth in the form of solar radiation, okay? Sun's rays. And that is really, it's really cool in that it can penetrate our atmosphere and it doesn't burn up. Like if you've seen movies or you've seen meteors crashing into Earth, they tend to catch fire, okay, as they're coming through the atmosphere. Okay, solar rays don't do that because they're a form of energy. They're not actually a solid particle coming through the atmosphere. There's no friction there, okay? They're just making their way. It's energy. It reaches the Earth's surface, passes through our atmosphere. So these rays, and I'm going to draw them nice and large, these rays actually come down and they warm up our planet. And to a certain degree, oh my goodness, are we ever lucky that they do? Because otherwise we'd have no liquid water. Okay, the greenhouse effect is important. We need it. We do not survive without it. But the problem now is that this used to be a really nice balance where infrared radiation would be made by living things and it would go back out into space. Okay? That was really great. That's the heat that living things create and the heat of our planet. Okay? So it was a nice give and take. We had enough heat that stayed on the planet to keep water in liquid form, not in ice, because animals can't drink ice and plants don't get ice into the soil and they can't use ice in their roots to help them grow. But what's happened here is with the onset of global warming, okay, our atmosphere has actually become, like we've got this layer of gases inside our atmosphere. And I'm actually going to make the atmosphere a little bit thicker for us to see. Okay, our atmosphere has become, let's say it's this thick. Inside our atmosphere, we have this layer called a layer of greenhouse gases. And what I mean by that is it's this invisible layer of gas that used to be about yay thick. Okay? And this is what used to cause, or I should say this is, even though it was still there, sun's rays could penetrate it. Yay, warming us up. Okay? Great stuff. We would make our heat and it would go out. All right, nice and easy. And you notice how there's one more ray coming in than going out, so we maintain some heat. That's great. Fast forward to the Industrial Revolution, and especially in the last, 60, 70 years or so, and human impacts have really, really changed this. So what we've done to the actual greenhouse level here is we see that it's getting thicker and thicker and thicker. Now, just like before, sun's rays can still penetrate it. So we're still getting a lot of radiation here, solar radiation, loving it. Okay, keeping things alive, awesome. But now, very little energy is actually able to escape out of the actual gases. Okay, very little is actually able to escape. What ends up happening here is it hits this, it cannot come back from it, and it's bounced back onto the surface of the planet, into our atmosphere. And this is what's causing the air to get warmer and warmer. This increased layer of greenhouse gases. So what ends up, why we call it a greenhouse effect, is this layer of greenhouse gases right here is acting the exact same way a greenhouse does. It's letting heat come in, but it's trapping the heat at the surface inside that layer of gases. So the atmosphere gets warmer and warmer. And this is what causes global warming. Global warming is caused by greenhouse gases. Greenhouse gases are what cause the greenhouse effect. This is why our planet is acting kind of like a ginormous, greenhouse made of glass. It's letting all of the sun's rays in, but it's not letting any heat out. It's trapping it inside. Here we've got what we call the carbon cycle. And this is the cycling, just like the water cycles through our planet, carbon also cycles through the atmosphere and living organisms. Now, what ends up happening here is carbon that's in the atmosphere is there in the form of CO2. So we will draw that in red. Okay, so we've got CO2 or carbon dioxide in the atmosphere. And luckily, we live on a planet that has a lot of organisms that need carbon dioxide to survive. They could not live without it. Plants make their own food through the process of photosynthesis. And photosynthesis is taking carbon dioxide from the air, water from the soil, and with the help of sun, like radiation energy, they're able to make sugars for themselves, and they feed themselves that way. We don't have that ability. That's why we're consumers. So here we're going to start off with a thicker arrow stating that carbon dioxide gets absorbed by the plants, in the process of photosynthesis. As those plants photosynthesize, they make their own sugars. They make a sugar called glucose. As a result of undergoing photosynthesis, though, another gas is made. And that is a gas that during the daytime, it's actually toxic to the plant. The plant doesn't need it, so it spits it out into the air. As a result, plants will release a large amount of oxygen. They spit out oxygen into the air. And this is also known as O2. O2 is oxygen. Awesome for us because animals, humans, anything that's living is going to require oxygen. We need oxygen to live. So that oxygen goes to you, and it's all great. In return, we actually undergo a reaction known as cellular respiration, which means we actually take the oxygen in and we break apart sugars to get energy. That's why we eat. It's to get energy. And we're pretty good at actually making energy from sugar. That process is known as cellular respiration. Funny enough, when we actually breathe in oxygen, we end up breathing out carbon dioxide. So this carbon dioxide goes up into the air. Oxygen goes in, CO2 comes out. It's toxic for us to breathe in carbon dioxide. We would not survive. Now, this, if we just look at this, if we forget that all this stuff to the right of the screen is there, this is a really nice cycle. It's a give and take relationship. The amount of oxygen being produced was pretty much equal to the amount of carbon dioxide being taken in by the plants. It was give and take and happy. But humans come along and we start inventing machines. And we start inventing machines that use non-renewable fossil fuels. And as a result, when factories burn fossil fuels for lights and to work their machinery, when cars burn fossil fuels to move around, okay, to actually operate the vehicle, we start seeing an increase in levels of carbon dioxide, okay? Which means that there's now more CO2 here than the trees can actually take up. And the sad thing is, in certain parts of the world, so if you remember my drawing from first page here, my nice little planet, okay, if we go back to that and we highlight the middle in pink here, the equator, okay, the middle part of the planet, those forests photosynthesize all year long. That's great, because the forests up here don't. We got winter. The forests down here don't. They have winter as well. So what ends up happening is in these areas that photosynthesize all year long, farmers are starting to cut down trees because they need more land. And if less trees are there, and we're making more carbon dioxide, what does that mean to the levels of CO2 in the atmosphere? It increases. Hence the thickening here of, oops, not that one. Hence the thickening here of our layer of greenhouse gases. Because more carbon dioxide is now in the atmosphere than when it was just this happy little give and take cycle. Okay, this is what we say, this is what we mean when we say that humans are impacting the amount of greenhouse gases in the atmosphere. We're making more of them. And we're also cutting down the trees that can get rid of them. So this carbon cycle is no longer a give and take. If we look at the thickness of our arrows, okay, here's our arrow of oxygen coming out. So this is O2. But here's our arrow of CO2 being produced. Okay, it is thicker, right? So if we've got more CO2 being produced than oxygen coming out, that means that CO2 is staying in the atmosphere, and it's thickening the layer of greenhouse gases. So by using more renewable forms of energy, we can lower the amount of CO2. Okay, so if we undo that, we can actually bring it back to normal levels where it is a give and take, and that's the goal. Okay, that's where the planet just keeps on chugging along and doing its thing.